This conference will now be recorded.
So very good evening, students. We were revising the chapter Electrostatics, first two chapters, and here we are just picking up previous year's JEE advanced paper. I mean questions from previous year's JEE advanced paper. So this is I have some 3 questions from JEE advanced 2022. It is actually wrongly written. Just a minute. (2022). So I have 3 questions. These questions are really lengthy questions, and also questions, since these are advanced questions, these are little bit thoughtful questions. So we'll solve these questions today. All right. So you can see this question here in this figure. In this following circuit, there are 5 capacitors, and they are arranged in this way. You can see this is a problem from combination of capacitors. Okay, so let me first write question. It is half written. So the value of the capacitance C1 is 12 microfarad. C2 and C3, they have equal capacitance, and that is 4 microfarad. And C5 and C4, these two guys have again equal capacitance. They have 2 microfarad. So the question is, this is a question of fill in the blanks type. The charge stored in C3 is dash. Okay, you have to find out that. Okay, so to solve this problem, first of all, we have to understand which capacitors, like which are connected parallel, which are connected in series, and then finally you have to do loop analysis, or we have to apply KVL to find out voltage, charge, and in case of resistance you have to find out current, etc. So these are very interesting problem. So whenever you have such 2 batteries and you have to do the analysis, then always we will take this dominating battery and see the plate which are directly connected to this, will take them as positive. So in that way, this is positive, this is negative, this is positive, this is negative, this is positive, this is negative, again this is positive, this is negative, this is positive, and this is negative. So what you understand from here, if we want to understand which are parallel and which are in series combination, we know if more than one capacitor, their positive plates are connected together, some at A, and negative plates are connected again together. then they are parallel. So this is parallel combination. This is parallel combination. And when two capacitors are connected in such a way that see negative plate of one is connected to positive plate of the other, and you say here is the battery connected like this. So these are actually connected in series. This is series combination. In this way we'll try to analyze here also. I'll tell you a few more things about series and parallel combination of capacitor. You may also know this and you can remember these things. See, whenever two capacitors are connected in parallel combination, see both of them will have the same potential difference across the plates. Same potential difference across the plates, right? But if you think of charge, charge may not be, if they are equal capacitors, then they will hold the same charge. But if they are having different capacitance, then they will actually store different charges, Q1, Q2, etc. What happens in case of series? In case of series combination, see the potential difference of each pair of the plates will not be the same. Suppose the parallel, see this capacitor has potential difference across the plates is V1 and capacitor 2 has potential difference across the plate V2, then V1 plus V2 will be the total potential. Okay, total potential of the battery. So this is an important point. Another point let me talk about charge over here. Since these two are in series, so whatever charge is stored in this capacitor, the same charge will be stored in the other capacitor also in this case, because see this is a continuous circuit, so there should not be loss of charge. So whatever charges are actually sent by the battery, that should come up to the negative. Okay, same charge will flow through the circuit. In this case, what happens, total charge may be Q, but it is the sum of the two charges. See, if charge Q comes here, so it is actually divided into Q1 and Q2. It comes like this, and then it actually combines to Q1 plus Q2 to make it Q. Okay, these are the important points which I wanted to make clear in the beginning of this solving this problem. Now, without much delay, let us see this circuit. See, since these two are, see this point, this is simply a wire, this is also a wire, and this wire is actually having the same potential everywhere. This wire has same potential up to here everywhere, right? So anyway, this point is common. See this point and this point, they are common point. That means they are connected as if they are connected at the same point. And these 3 points also are same point, because this is simply wire, conducting wire. So this, suppose this is A, this is B. So A, B are actually the same point. Here if I say C, D, E, they are actually the same point. Okay, same point. I'll go to the next page and try to draw the equivalent circuit for this. Okay, you just keep this figure in your mind. I'm just trying to draw equivalent circuit diagram for this. See, I have 6-volt battery, positive is here, so I have C1 here, and see Let me draw this. Here is the other battery. This is 2 volt, this is 6 volt. My equivalent capacity circuit will be, all others are like this. That means this is C2, C3, C4. Okay, so 2, 3, 4, 5. I have drawn on extra. Let me just erase that. So C3 and this is C5. Okay. So these are all parallel. Look, their positive terminal is at this point A, and I say this is D. So in between A and D, all of them are between A and D. This point is A for all of them. And this is D for all of them because this is conducting wire. All right. That means what? I have to replace these 2, 3, and 2, 3, 4, and 5th capacitors. This C2, C3, and they are actually parallel in combination. Okay. So C2 parallel to C3 parallel to C4 parallel to C5. Okay. So equivalent capacitance will be just C2, C3, and C5. We'll just replace all those four by equivalent capacitor having the capacitance C2 plus C3 plus C4 plus C5. If I do that, so what is this equivalent capacitor will capacitor will have the capacitance. See, I have C2, C3, both of them are 4, and these two guys are 2. So I have 4 into 2 plus 2 into 2. Okay, so this is microfarad. So this is equal to 12 microfarad. Now see, this is 12 microfarad, and equivalent capacitance will be also, let us say this is equivalent, this is also 12 microfarad. Now look, I have taken this as positive, this as negative, this is positive again, this is negative. So these two are again in series. So I can actually just take the series combination of these two. Series combination of these two, so equivalent circuit will be so this is C, again C equivalent, this is 6 volt, this is 2 volt. Okay, so what is the equivalent capacitance of these two? We have to find out. See, it is 1 over C is equal to 1 over C1 plus 1 over 12 microfarad, this one. So both are actually 12. So I can just do one thing. I can just write multiplication C1 and C equivalent by addition. Both are 12 actually. Okay. So this is 12 plus 12 microfarad, and this is actually 12 into 12 microfarad, right? 12 into 12 microfarad. 12 into, so this is 2 into 12. I'll just erase. So you get actually 6 microfarad, half of both. Okay, 12 goes off, this is 6 microfarad. Okay, so I have got here 6 microfarad. 6 microfarad. So now I have got a circuit where I have a capacitor and two batteries. So in this case, how to find out uh, voltage across this, because I have to ultimately find out what is the charge. If this is carrying, see, since these two are in series combination, if this guy is storing Q charge, this also will carry store the same charge. Then I can go back to the original figure and then try to find out which one among these parallel capacitors, like among them, which one is storing how much charge. Okay, so here, see, I'll just use Kirchhoff's voltage law. Okay, this is plus, say this is minus. I'm going in this way. So this is plus, this is negative, this is positive, this is negative. So if I use the KVL, look, this is plus 6 minus, see, since I'm going positive plate to negative plate, okay, in this way, okay, or in the other word, charge is flowing as if it is from negative uh, plate, so that's why I'll take negative voltage across this. So we know if the charge stored in this capacitor is Q, we know the capacitor, so I can get the voltage, so that will be Q by C, because V, yes, so Q is equal to C into V, so V will be Q by C. Okay, so Q by 6. Okay, 6 is anyway microfarad, so this will be microcoulomb somehow. Okay, so that it will be a volt, this will be microcoulomb, Q microcoulomb. And again here also it is going from positive to negative, or as if the current is passing emerging out from negative terminal of the battery, so that's why I'll take negative voltage, so this will be 0. Okay, anyway this will be volt in unit, so I'm not keeping this to. Okay, so this is, look, this will give you Q is equal to, so this is 2, this is 6, so it is 4. If you go that side, it will be minus 4, so minus 4 into minus 6, this would give you 24 microfarad, sorry, microcoulomb. Okay, now come here, so this is 20 microcoulomb, 24 microcoulomb. So this also, this branch, if you, so all this parallel, so the total charge in all these 4, the total charge Q will be 24 microcoulomb. That is what I just wanted to mean here, 20 microcoulomb. Okay, so the total charge, like I can write Q2 plus Q3 plus Q4. Okay, Q4 and Q5, Q4, and this is Q5. So all, if I add Q2 plus Q2, sorry, Q2 plus Q3 plus Q4 plus Q5 will be 24. Okay, Q2 plus Q3 plus Q4 plus Q5 will be 24 microcoulomb. Okay, I have actually made it very heavy. I'll just erase these things I don't require now. Let me just make it a little bit clean. At least you have understood this. Okay, so this I'll just clean it. Okay, so look, this C1 and a whole this combination is in series, that's why this will be storing 24 microcoulomb, and all together they will actually store how much? 24 microcoulomb. Now see, I have C2, C3. These are 4 microfarad. Okay, microfarad. This is so we have to actually find out. Look, since these two are see, we have now charge across this. See, we have charge across this, and total equivalent capacitance also we have. So if we want to find out, charge across each of them, we first of all we need to know across the plates what is the potential. So that we have to find out first. So look here, I'll just erase some of the things here also. So I have got now charge across this and capacitance I knew. So charge across this, we have got Q is equal to 24 microcoulomb, and we know the equivalent capacitance across this, okay, of this capacitor. So what is the potential difference across this? Suppose this is C and this is D, across C and D. So it will be actually charged by C equivalent, and that is the potential difference across CD. So this will be 20 microcoulomb over 20 microfarad. So it will be actually 2 volt. So look, across this branch, the potential difference will be, across this branch, the potential difference, if I say this is C and this is D, okay, so VCD is actually 2 volt. That means each of them are actually between this 2 volt, or potential difference across each plates, like across each capacitor will be 2 volt. Then we can actually calculate charge stored in each of them. See, now I have to find out Q3. Q3 means C3 into V, so VCD, right? So C3 is actually 4 microfarad and this is 2 volt. So this will give you 8 microcoulomb. So the charge stored across Q3 will be 8 microcoulomb. So this is a lengthy question. Actually, I made it lengthy to uh, just to make you understand how step by step we can do this. Okay. All right. So this is the way to find out the answer. Since it is advanced question, so these questions will be a little bit lengthy and conceptual. Okay. So we'll go to the next problem. So this is also again a nice problem, but not so tough. We'll be able to solve it very nicely. Okay, so the problem says a medium having dielectric constant K greater than 1 fills the space between the plates of a parallel plate capacitor. The plates have large area, and the distance between them is D. The capacitor is connected to a battery of voltage V as shown in the figure A. You look, this is the figure A, where we can see the space between the plates of a parallel plate capacitor is filled with a dielectric material having dielectric constant greater than 1, and the plates are separated by a distance D, and the plates are connected to a battery of voltage V. Okay, if I have to find out capacitance for this particular configuration, so we can be easily able to find it, right? We know if this is C1, this will be K C0. C0 means air capacitor, capacitance of air capacitor when there is no material, no dielectric material, there's only air. Okay, so this C0 is actually epsilon 0. A is the area of the plate and D is the separation. Okay, so ultimately K C0, sorry, K epsilon 0 A by D will be the capacitance of this configuration. Okay, if we want to calculate that, we can easily find out from here. K epsilon naught A by D. Okay, now the question is, now both plates are moved by a distance d by 2 from their original positions. See, both the plates, suppose this is plate 1 and this is plate 1, this is plate 2. See, they are actually earlier they were having gaps exactly equal to the width of the dielectric material, that was D. Now separation has become actually 2D. You look how, so this plate has been moved here by D by 2. Excuse me. So now both the plates are actually moved by D by 2, as you see in the figure B. Okay, from their earlier position. Okay, so figure B is very clear here. You can see that the situation is shown over there, that both the plates are moved by a distance d by 2 from their original positions as shown in the figure B. Now the question is, in the process of going from one configuration A to the configuration B, which of the following statement or statements, that means there may be more than one answer correct among these 4 options. So we have to find out the answer for this. So look, this is a very nice question. See what happens actually. See, how do we calculate capacitance? Generally capacitance can be found out by C is equal to Q by V. We know Q is equal to CV, right? Okay, and C will be found out V by Q. Q is sigma into A. Okay, we know that, and this is V. V is equal to E into D. Okay, if we go with that, look, first of all, what we have to do, we have to find out the potential difference across this, and across this. Okay, and then separately I have to calculate the field for each of them. See, obviously field will not be same here and same here, because there is dielectric material over here, so field will be like, it will be less than this here. Okay, we'll see that. So let us, I mean, dielectric material, so there will be a greater field here than this. Okay, let us go to the next page and see. So in this case, capacitance in this configuration, obviously we know that we have already calculated that. This is epsilon k epsilon naught A by D. So here it is C1 is equal to epsilon 0 A into K, obviously K epsilon 0 A by D. But in this case, let us say here it is electric field U1, this is E2, and this is E3. So total voltage V will be actually E1 into D by 2 plus E2 into D plus E3 into D by 2. Okay, so we know that E3 see if we want to find out the potential, let us see what is electric field here. What is here? See, E1 will be sigma by epsilon naught, sigma by actually 2 epsilon naught, right? Sigma by 2 epsilon naught, but here it will be actually E2 is equal to sigma by 2. There are two sides. Obviously, this will be sigma by epsilon naught, and this will be sigma by sigma by k, sigma by k epsilon naught. Okay, sigma by k epsilon naught. So therefore, see the electric field at this E2, sorry, E1 and E2, they are, sorry, E1 and E3, they are equal because both are in the vacuum or air. This will be k times the E2. Okay. So what we can write here, this V, total V, how much we can write? If we just consider this discussion here, E2 is equal to this, so we have E1 is equal to E3 is equal to KE2. So we'll write here. So we have E1 is equal to K E2, okay, by d by 2, so that will actually make you 2 into d by 2, so this is k into E2 into d, and here it is E2 into d. Okay, so I'll just erase, or let me write another line over here. So the V is actually E2 k E2 d plus E2 into d, right? So this will make you get E2 into d, right? So this is the total potential now across this. This is k plus 1 E2 d. So what is the capacitance then? Capacitance C2 of this configuration will be how much? It will be simply E1 by E2, right? E1 by E2. Okay, so E1 by E2, sorry, here, yes, E1 by E2 is actually k plus 1. If we want to write, we can write that. But anyway, so what is the capacitance? Let us write that. C2 will be actually written as epsilon 0 A by d plus d by k. Okay, this is the one. So it is actually epsilon 0 A. If I take d common, then it is k plus 1 over k. Okay, so it will go here as epsilon 0 A into k divided by k plus 1 into d. Okay, I'll write clean. I'll clean this portion and write here. Let me write it here. So what we have got, C2 as epsilon naught A, k epsilon naught A by k plus 1 into d. So earlier what was that? This one. So C1 by C2 we can find out. If you want to calculate C2 by C1 or C1 by C2, C2 by C1, let us say C2 by C1, k epsilon naught A by k plus 1 d, and this is k epsilon naught A by d. D will go in the numerator, so this will be cancelled. Okay, so this will be 1 over k1 plus k2. Okay, that means what? C1 is, this means C1 is k1 plus k2 times C2. Now look the options. The options are, first option is the electric field inside the dielectric material is reduced by 2k. Okay, is this true? electric field we have seen. Electric field was E1 by E2 was actually, so how much it was? Actually, E1 was K times, sorry, not K, it was, see, this was, yes, so it was K times E2, okay, K times, not 2K, it was K times E2. That means it was reduced by K times. E2 by E1 will be 1 over K. It is reduced by K times, not 2K times. Okay, so the first option is not correct. So therefore, the first option is not correct. Now, the capacitance is decreased by a factor 1 over K1 plus K2. Look here, it is true. C2 by C1 is 1 over K1 plus K plus 1. So C2 by C1 is 1 over K plus 1. That means what? The capacitance is reduced by a factor this. This is true. Now the voltage between the capacitor plate is increased by a factor K plus 1. It is also not true, because we have seen the voltage is actually, voltage in this case, if we write sigma by K epsilon 0, this is electric field into D, okay? So if we multiply a both place, okay, anyway, so the sigma by K epsilon 0, and if we multiply, okay, so in this case it was electric field in this was E2. The question is the potential, right? The voltage between the capacitor plates is increased. So voltage we had calculated. What is that? Voltage is actually K1 K plus 1 into E2 into D. E2 into D is the voltage of this here in the dielectric material, which is actually unchanged. Okay, this is actually multiplied. This is actually increased by K plus 1 times. Yes, it is also correct. Voltage of the capacitor. Yes, voltage of the capacitor plate is increased by K plus 1. Okay, that's why this much is the reduction in the value capacitance. The work done in the process depend on the presence of the dielectric material. So now we have to see when does not depend, it says does not depend. It says does not depend. We have to see how it depends on, like, what is the work done. We can just calculate what is the work done. So work done is actually, work done will be half CV square, right? So C is here, work done, that means the net work done, if we find out, then it is C2 minus C1 over like half C V square. This is the net work done. Okay, net work done. So what is the net work done? C2 we know, What is the capacitance? So we know the C2 is actually, let us write that, K epsilon 0 A by K plus 1 into D here minus K epsilon 0 A by D into V square. Okay. Actually, I should have done this as C1 minus C2. Okay, C1 minus C2 because the capacitance has got reduced. C1 minus C2. So it will be half. So C1 we know K epsilon 0 A by D minus this is K into epsilon naught A by K plus 1 into D. Okay, into B square. Look, I'll take this common. K epsilon naught A by 2D, and it will be 1 minus 1 over K plus 1 V square. If we do the calculation here, look, this is K plus 1, this is minus 1, so it will be K, so it is actually K square epsilon naught A by 2D K plus 1. Okay, so and into V square. So we can see in the expression of the work done, here we have the dielectric constant, right? So if we even take a little bit of approximation, see if I take common, this will be K epsilon naught A by 2D 1 plus 1 over K. Okay, K is greater than 1, so I can just do, for the sake of approximation, I can write at least this is K epsilon naught A V square divided by 2D. At least I can, if this K is greater than 1. Okay, I can just neglect this part. At least I can write this. Okay, so it is depending on the dielectric material. So the option D is not correct then. So this is not correct. So B, C were correct options here. Okay. Now we'll take up the last problem for today's discussion. This is also very interesting problem. Let us quickly solve this problem. So this problem says 6 charges are placed around a regular hexagon of side of length A as shown in the figure. See, this is the figure. This is a regular hexagon, as you see, and around that, symmetrically the charges are placed. Symmetrically charges are placed. Okay. 5 of them have the charge Q. See, Q, 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 and all are Q. They are not in the vertices. Okay, not at the vertices, but they are symmetrically placed. Okay, and see, this place is empty. That means I have to place charge and see what happens. So one place you see, and the remaining place one has charge X. You don't know that. The perpendicular from each charge to the nearest hexagon side passes through the center of the hexagon and is bisected by the side. That means if I see here, it is shown. See, if I just draw a perpendicular up to O, then this perpendicular is bisected. Okay, if this is total is 2L, then it will be L, here it will be L. Okay, it is bisected, right? So this is one point. So which of the following statement that can be more than one? Options correct? So which of the following statements is or are correct in SI units? Okay, so let us see the options first. When the X is Q, the magnitude of the electric field at O is 0. That we have to see. Let me first of all make you understand this problem once again before we solve the problem. Okay, so this is the regular hexagon. If I connect this point, this vertices with the center, you will get equilateral triangle. This is equilateral triangle. That means if the side is length of the side is A, this is also A, this is also A. If we want to find out the distance, this will root 3 by 2 into A, this distance. So bisected means this distance also will be root 3 by 2 into A. Okay, that means for all of them the distance, see these distance are actually, I'm sorry, okay, let me just clean. So I'll add them with the dotted line. This is exactly opposite to this position. Okay, here. Okay, and this is in this way. Opposite to this is this one, and these two are in same line. And see, they are actually equal distance from each other. So as I said, this will be a this will be an equilateral triangle for all of them. If you just add, this also will be equilateral triangle like that, since it is regular hexagon. So this is A, this is A, this is A. So this height will be, I'll clean now, height will be root 3 by 2A. This height, because this is bisected, this perpendicular is bisected, so this also will be root 3 by 2, and this also will be root 3 by 2. So if I want to know the distance from charge to center, each charges to center, so the distance will be 2 into, let us say that distance is D. D is root 3, 2 into root 3 by 2 into A. This is the distance from each of them up to the center. Okay, all of them, okay, will be a D distance away, and D is root 3 by A, 2 into root 3 by A, sorry, 2 into root 3 by 2 into A. This is A actually. A is the length of the side of hexagon. Now look, I have to calculate the electric field. See, since these are all positive charges, if I keep another positive charge over here, Q, the electric field will be directed this way, and from here will be this way. So these two guys will be cancelling each other. Similarly, these two guys will be cancelling each other. Okay, and these two guys also will be cancelling each other. So ultimately it will be 0 over here. Okay, this is correct. So the first option is correct. The electric field will be 0 at this point O, because all the charges are same, and all of them are actually symmetrically situated. Okay, so the electric field will be 0 if I place Q charge plus Q charge at this point X. Okay, now the second point, if the charge is minus Q, if the charge is minus Q over here, then what will be the electric field? This is very interesting. So what will be the electric field? Look, if this charge is negative, look, these guys, they will actually cancel each other. These guys will cancel each other. Only thing is here, see, this one will be directed. So electric field due to this Q will be directed this way, and due to this also will be directed in this way. So they will be actually added up. Electric field due to this plus Q and electric field at X, that is minus Q, they will be added up. So there will be no zero electric field, there will be some net electric field. So how to find out net electric field over here? See, I can take this two, because these are additive, I can take as if there is a charge 2Q over here. If I calculate electric field due to this 2Q charge at the center, then it is done. I hope you understood this. So if X is equal to minus Q, then electric field, then electric field at O will be obtained. In SI unit, what we know, electric field is equal to Q by 4 pi epsilon naught. Here Q is 2Q. As I said, you can see both are Q and Q, right? Both are in the same direction. So I can take, instead of calculating, instead of writing Q by 4 pi epsilon naught plus Q by 4 pi epsilon naught, I can take 2Q here itself. Okay, I hope you understood this, or else I'll write in this way. Q by 4 pi epsilon naught distance square. Distance means d is actually 2 into root 3 by 2 root 3 by 2 into a sorry, a is here numerator, so 2 goes up, so this will be root 3 into a whole square. Another charge Q by 4 pi epsilon naught, and the same root 3 whole square, right? So this is what I just wanted to say, that if you just take 2Q, that's all. So you'll get actually 2Q by 4 pi epsilon naught. This is 3a square, right? So yes, so this is the thing. So let us see the options. Option is actually Q by 6 pi epsilon naught a square. So see, this is 12 pi, so it will be 6 pi then. 6 pi epsilon naught a square. Okay, so this is correct option. This is correct. Now we have to find out what is potential. The question is, so I'll clean this portion because I have to go for another option. Option C says if X is equal to minus plus 2Q. If this is plus 2Q. See, for the case of potential, it doesn't matter because all of them will be producing some potential over here, right? All of them will be creating some potential at this position. Okay, so what we can do, I can write Q by, see the potential, I know these are all equal, so what I can do, I can see X is equal to 2Q now, 2Q, here 2Q. I can write 5 into Q by 4 pi epsilon naught. A means root 3 into A. Okay, plus 2Q by 4 pi epsilon naught root 3 into A. So what we get? So we'll get eventually we will get 7Q by 4 pi root 3 epsilon naught A. Okay, let us see this is the option which is correct. Okay, that's all. And the last option we will see, if this is minus 3Q, what is the potential there? See, minus, here itself will write, see, if the last option D, it says if Q is minus 3Q, so anyway we know this is 5Q by 4 pi epsilon naught root 3 A, and here I have to minus this 3Q 3, so it will actually become, actually 2Q by 4 pi root 3 epsilon naught A, and 2 if you just strike off, then it will give you 2q, here 2 pi root 3 epsilon naught A. Okay, but what is the answer given? So this is the answer. It is not true. Okay, so we see here A, B, C, these three options are correct. So this is how we can solve this problem. We'll stop it here for today. We have solved 3 problems from this electrostatics chapter, and these are from actually JEE Advanced Paper 2022 Part 1. Okay, next I will take up few more problems, and then we'll go to the next chapter, third chapter. Okay, so thank you for your patience. Bye for today.